This video is on electron dot diagrams, also known as Lewis structures. You will need your periodic table for this video, and you'll find this information on pages 184 to 185 in your book. So it's actually in a later chapter than what we're in right now, but we're going to teach it now because it goes with what we're doing and it leads us into later on. So electron dot diagrams, or Lewis structures. What you'll see is, first of all, you're going to see the symbol for the element. And the symbol represents the nucleus and all of the inner level electrons. By inner level, I'm talking about every single electron except the outermost ones. That's what the symbol represents. We don't need to know how many electrons or anything, that's just what the symbol shows us. Outside around the symbol, you'll see dots. And these dots represent what we call the valence electrons. So the valence electrons are the outermost electrons. So let's make a note of that. So valence are outermost electrons. So the furthest energy level away from your nucleus, this is just going to show us dots for how many there are there, how many electrons are there. The maximum you'll ever see is 8. We'll talk about why and all that later on. For right now, you just need to know that 8 is the most. Okay, so this is going to reflect the same pairing as in the orbital filling diagram. And I'll show you what I mean with that in our examples. When you put your dots on your symbol, okay, so let's say we have a made-up element, element X. So there's our symbol, okay, and remember the symbol represents inner electrons, okay, so instead of drawing them, writing them, we just write the symbol. Where we put the dots around our symbol actually matters. First of all, I want you to think of this as having 4 sides. A top, a bottom, a left, and a right. So top, bottom, left, and right. All right? We don't actually draw those lines, okay, but that's where they're going to go, and they're going to go in pairs. Okay, so just like you would see in our orbital filling. So 2 on each side gives us 8 total. So you're going to fill your electrons in, number-wise, in this order. So your first 2, oops, there you go. Your first 2 will go in those spots. Okay, so if you had something like beryllium, beryllium has 2 valence electrons, so you would draw it like this, 1 and 2. Okay, the next one, if you had another one, you would write down here, 3. Okay, if you had 4, you write it over here, and then 5 would be here. So the reason they're like this is these 2 are in our s orbital, in our outermost energy level, and these 3, so this one, and this one, are in our p orbital, or p sublevel, I should say, because remember, p has 3 orbitals, so you'd have 1 electron in each before you went back and doubled them up. So if you had more than 5 valence electrons, that's when you would go back and pair them up. So the next one would go 6 next to the 3, 7, right? Now we're doubling them up, 8. So it's just like when you do like 2p, for example, right? 2p has 3 orbitals. So here's your first one, your second one, your third electron. That was the 3, 4, and 5. And then the next 3, that's when you go back and double them up. Remember, you put 1 in each one before you double. Okay, so let me show you some examples with some actual elements. All right, so these elements, for examples, are exactly the same as the one in the last video. So if you look up at the top of your page where it says example, draw the orbital filling diagrams, you have these same elements. So here, I just copied it down here. You should have this for boron already written on the top of your page. So look at that. First, we need to figure out where our highest energy level is. Well, it's going to be, remember the energy level is this first number, so we've got 1 and then 2. 2 is the highest value. So these are valence electrons. Okay? So look how many electrons total there are. 1, 2, 3. So we write our symbol, boron. Actually, I'm going to write it over here, boron. And we write that there are 3 valence electrons. So we start by putting them, remember, in the spots on the right side, 1, 2, and then 3. So there's your Lewis structure, your electron dot diagram for boron. Let's do another one. So now you have, let's see, sulfur. And you have this written on the top in the last example as well, for the last video. So we've got, let's see, our energy levels are 1, 2, 2, 3, 3. So now our highest energy level is 3. Here and here, right? 3p and 3s. So count how many electrons you have. Remember, each line is an electron. 1, 2, 3, 4, 5, 6. So we've got 6 valence electrons. So we first write our symbol, S. And our first 2 are from the s orbital, so they're next to each other. 1, 2. Then our next one is 3. And then 4. We're going around. 5. And now we have to double them up, just like we did over here, right? We did 1, 2, 3. Okay, right, we filled them all singly. And then we have to go back and we can double it up. So now I'm going to go back and put my 6th one there. Okay? One more example. So this strontium, you have above as well. So our highest energy level here is, if you look, we've got 1, 2, 3, 4, 5. That's it, only 5 in the one spot. So we write our symbol, strontium, Sr. And then our valence electrons, there are only 2 here. Right? They're in the S, so the only 2 are drawn like that. And there's your electron dot diagram for strontium.